Hello everyone, welcome to my channel and welcome to this topic, Siemens TI Portal, graph programming, tip and tricks, and my personal experience sharing. And in the previous video, I used this Siemens Step 7, the classic software. And I showed from this OB1 we called FB10, and this is sequence 1. And I shared some of my experience. From here we open and we discussed some settings, the timer and supervision mode, and some other tip and tricks. And in this video, I will use the step 7 as a base and share some tip and tricks in TI Portal software. And all in all, after Siemens released TI Portal software from more than 10 years ago, this platform improved the graph programming a lot, especially if you are still keep using i7-300 or i7-400 controller. You can still use TI Portal, this software, and migrate your classic project, Step 7 project, into the TI Portal platform. And again, this platform can program 300 and 400. Personally, I would highly recommend, if you could have any chances upgrade or migrate your project into TI Portal, I would highly recommend you start using the TI Portal to program your control system. Okay, so back to this graph. Like now, I'm using the 1500 controller. And here, the latest platform from Siemens PLC, it has 1500 series and 1200 series. Unfortunately, the 1200 series does not support the graph programming. Maybe from TI Portal version 20, that 1200 G2 series might be the new series controller could support, started from TI Portal version 20. But currently only 300, 400, and 1500 PLC support the graph programming. If we create a new function block, and here it shows graph, but 1200 area doesn't have this option because 1200 controller does not support the graph. Okay, so here I will briefly introduce how can we create a graph, but we will mainly focus on the tip and tricks experience sharing in this video. Okay, we can firstly create a FB here function block because all those graphs locate inside a FB function block. So select the function block and create a graph. After create this graph, you will see your program list. It will show the function block graph. And then go to your FC or OB1. You can drag your FB. And meantime, it can create one instant DB. Okay. So here I declared one instant DB already, so I can drag this instant DB to here. By default, you do not need to connect anything at the left side. By default, the graph will go to automatically run mode. Especially for the case if your sequence, once it reaches the end and it loop to the beginning, so basically your sequence can keep running. Then you can use your command and transition to control if the sequence can keep running. By default, you do not need to connect anything on the left side. Unless you try to intend to control something, we can introduce shortly after. Okay, especially while we are doing the commissioning, we can use the control panel to control all those important commands. For example, how to switch from the auto to manual, how to force jump to one specific step, and how can we stop this sequence. And then let's jump to the graph. So here I create this graph already, so I'm gonna jump in. Okay, here in this graph, so firstly left side we can see this is a global view. We have the step 1 to step 6, and the final step, this is I manually change the number to 999. This is my personal flavor. I always change the last step to 999. That means this is the last step. And in this sequence, I defined this. So if I delete this, I define as the sequence end. That means once this sequence finish here, it will not automatically jump to the beginning unless I manually initialize or use any command to initialize to the first step. Or you can program this, just delete this and click this and jump to the beginning. So the jump to the S1. The S1, this is the first step. At the first step here, that means once we finish this sequence, the sequence will jump to the beginning here. and then waiting for these two conditions. Once this condition on, then this sequence will start over again. Sometimes we don't like the sequence automatically start over again. That's why we could set to the end, set to the sequence end here. And then we can use any other command from outside when we call the function block, control this sequence, initialize, and start over again by any command from outside. Okay? And then when the sequence finish, at the last step, 999 here, typically I will do this way. I will create two signals here. One is the S1. S1 means the incoming event. And from here, we can click this drop-down list, and we can see S1 means incoming step, and ISO named outcoming step. That means when this sequence run at this step, at the moment when it jump to this step, it only have a rising edge event, and that rising edge will set this sequence complete signal. That's basically a flag signal. I usually call this STS status. So we set this status. And in the meantime, this is also my personal flavor. I will still use the S1, this rising edge, and use this N command. N means coil, right? And control this bool. This bool can come from a DB or M address. And this bool will be a rising edge, just one cycle on. This can be used for trigger anything. For example, this bool can be used to set any other flag or trigger other sequence start, some other purpose. So basically I have one flag signal and one trigger command signal represent this sequence complete. And keep in mind this, because I set this command here, then the first step, when we jump out of this step, then I will use S0 and reset this flag signal. Okay, S0 means outcoming step. Okay, that means by default, this step will be hold here, wait for these conditions, and jump to the next step. Basically, that moment, this sequence start working for something. And once we jump out of this step, then it will trigger this outgoing step event. This outgoing event will reset this flag. That means while we are running this sequence, this signal is off till the last step. When we jump into here, this complete signal will be on, stay on. So this stay on basically means a status of your sequence. Okay, this is the complete signal. Then some people will question, so I know the Siemens is doing this step control. It looks very rigid. I definitely can use the ladder logic and do some structure to program the similar style as it's a sequence control. Like one video I showed 3 years ago, if we recall. So for 1200, because 1200 doesn't support the graph, right? We can definitely still use the ladder logic to implement the sequence control. For example, this is a typical structure like this. So we are using the step number. Once this step number equal to 1, then we fire a status signal, and this is the transitional condition. So we can put some condition, here. And if we compare, these two conditions will control jump to the next step, to jump to the number 5, right? So this will be similar idea. These two conditions will be similar here. So these two conditions control this step, jump to the next step. And the right side of this action area, back to the ladder logic, once we arrive this step, we can use this signal as a command to control any other output, trigger the valve or servo drive control command, right? And this is the next step, which sequence number we will jump to. So for example, here I write 5, then we can jump to the step 5. No problem. However, you can think about this. There are two drawbacks by using the ladder logic to implement this sequence control. If there's any chances we have to do the branch control, from here we have to do a branch. For example, with one condition, we have to jump to number 5. With other condition, then we have to jump to the step 10, right? So using this way, we can do the jump. However, when your sequence become more and more complicated, your jump branch will be not that intuitive. When your sequence become more and more complicated, it's very hard to well manage branch control. This is the first. Second, the number. Like here, I usually use 5 as an interval. So from 1 to 5, and next I will use a 10. Next will be 15. However, even I leave 4 or 5 numbers as my spare here, but in case this area need to be insert more than 5 steps, that will be a very tough, because that time your number has been well assigned to any other purpose. Then around here, you need to insert more than 5 or even 10 or 20 steps between here. Then your number will become very mess, especially for those numbers you are manually managing them. So this will become very complicated and hard to manage. If your project is being programmed by one person, that will be fine. But if this is one huge project and this project has more than 20 sequences, and in each sequence, sometimes maybe 2 or 3 programmers need to work on this one sequence together, then this number and a jump and a branch will be very challenging. Then go back to the graph. The graph will provide you a very clean and well-managed style. So like this style, right side is action, left side is transition, right? Then I can click this close all, then it will show you this main branch. So even if your system has the branches here, and it can do the multiple branches here, right? And from here, you can do the step and the transitions. This is the actions. And this is the transitions, the condition jump to the next one. And also you can close your branches to here. That means this and this, they are parallel. And this, we can do other transitions here, right? And sometimes either you can close this loop, or you can directly click this jump. You can manually point to, say, I'm gonna jump to number 3. Okay, so your sequence can be very flexible, intuitive. You can very well manage your sequence branches. Typically, each branch is one specific task, and the condition to run this branch could be here, right? You can either run 2 branches together, or most of cases will run 1 branch at one time, right? So you need to carefully manage your condition. But once it jumps to these branches, it will be very clear, because once it jumps to here, it will be highlighted. You can very clear to see what is running. And in the meantime, you can expand or close. Expand, then it can open everywhere, and you can open this step conditions. If you are doing step-by-step commissioning test, so this will be very easy. But basically, once you finish all the specific sequence tasks, then you can close this style, just monitor which step is running to have this global picture view. Okay? And then we can also see this main sequence now is using 2, 3, 4, 5, 6. Then if you add something new, for example, now if I'm trying to add a new sequence at here, then this sequence is 10 and 7. This number looks very messy, right? So, but don't worry. After you finish everything, you can go to the first step. You can go to the first step and then go to edit and go to renumber. And here we can assign, okay? We will reorganize the steps and the transitions. And then I can click the OK. So we can review those numbers. Click OK. Boom, we can see all those numbers got reorganized. See? 8, 9, 10, 11. Very well, right? So you do not need to care that step number anymore, because so this structure will help you to run step by step, and all those numbers will automatically reorganize for you. So here, do a quick summary. The branches and the number arrangement, this graph will be very efficient for you. This is much easier than the ladder logic programming style. Okay? I will delete this area and go back to my personal programming here. Okay, I will do a renumber again because I delete the sub branches. Okay. And once you finish the program, then let's download the program. Now I'm using, okay, let's download and go online. Okay, now my step is at this step 2. So once at this step 2, if we go back to the code area going online, and we can see the current step number is showing 2. So because we are at 2. Default, all the left side command, they all off. Default, they could be all off. When it's off, that means this graph will be at auto by default. Okay, if we go right side, we can see your sequence will be default will be at automatic. That means any condition they are on here, it can jump to the next step. So for instance, if now I turn on this, boom, it jump to the next step. Okay, if it jump to here, boom, it jump to the next step. Oops, why is here showing orange? That's because here I'm using the interlock. And the right side we can see, so for this N control, we are using the interlock as the precondition. So from here we can see the difference between this with C or without this interlock. So when we add this step, if the command doesn't have any precondition here, we can see the right side. The right side, this number 4 has been on because we are at this step, and this N means we are controlling this output. It's being controlled, so it is true. But this N here, this action, its precondition is a C, and is waiting for this interlock to be on. Okay, now we jumped in, and we can go to this interlock, and we can see this interlock is off. And because this output is waiting for this interlock, that's why this is off temporarily now. So this interlock typically could be used for tool interlock. For example, if we are going to control a cylinder, but this cylinder now is waiting for another cylinder go back to home, then allows us to run the current cylinder go to work position. So this can be used for this purpose to prevent the tool crash. And another example, if you are using this command to control the servo drive, right? This servo drive need to wait for any other tool clear, and then this servo drive will come down to clamp something. So this can be used for this command precondition. So now if I turn this condition on, we will see this step will be on soon. Okay, on, but it turned green and this stay true. Okay, if I turn this off, then this command will go off back again. Okay, so I'm gonna turn on. So this stay on. Okay, but if this condition is off, it doesn't cause any trouble on running to the next step. It's only used for control the specific command at this action area. So now I leave this off. Let's go back to the sequence here. Go back to the sequence here. I will click this button, sequence view. Okay, we are at here. It's waiting for this condition here. Okay, if now I click this on, boom, we can see even the interlock is not on, but it doesn't cause any trouble on this sequence run. Jump to the next step. It's only caused the interlock for this specific action here. This is the interlock we are using. Then the next topic is the supervision. Compare with the interlock. In some cases, we do like to temporarily hold your sequence. For example, while we are running the sequence, if the motor got a fault, or your process somewhere has some alarm, you do like to temporarily hold your sequence, doesn't want to keep going this sequence. How can we do that? So we can use the supervision, like this step now. So we run to this sequence, we run to this step, and if we jump to the inside, so here, interlock is okay, but the supervision now, I'm using a supervision here. So this supervision, I'm using a fault command connecting this supervision. If there's a fault from 0 to on, that means fault occurred. Then this step will turn red. Okay? if we go back to the sequence view, we can see here this step shows red. That means currently, even this condition on, your sequence will not run, will not jump to the next step because it's the experience of fault. Even this fault gone. If this fault got fixed, so if I turn off, we can see the sequence still not running. The sequence still being held here. Okay, the condition all good, but the sequence still red. The green here that shows if the fault got clear or not. Now we clear the fault. Now this V shows green. However, because this is supervision mode, it's waiting for us to do acknowledge. That's why I call it supervision. To acknowledge this step, if we are using the command, using the program to acknowledge, we can control this command, this one. We can turn to true. Then your step will go to the next step. It will be acknowledged. Or if you are testing your sequence, you can go right side and use this sequence control panel and click this acknowledge to do that. So I temporarily turn off this transition. Okay, so it will not jump to the next step. Let's see what will happen if I click this acknowledge. Boom, it will turn green. Okay, good. Again, if I turn this fault again, okay, now our process is experience of fault. Okay, I go back. Now it's fault. Okay, if I acknowledge, it's not working because we are experience of fault. Okay, jump in. If now the fault got fixed. Okay. If fault now got fixed, jump back. Here we can see this V turns green. And this time I will use my program, Float. I will use this one, acknowledge, and let's see. So I will use a program to acknowledge. Acknowledge, then once it got a rising edge, then this fault got acknowledged. And after the acknowledge, then it will depend on this condition. Okay? Okay, this is supervision mode, and we can see the difference between the interlock and the supervision. Interlock typically is being used for any tool interlock, the precondition for any action. But the supervision is and typically try to temporarily hold your process and wait for the higher level people to do the acknowledge to keep running your sequence. This is the purpose. In the meantime, I do like to show the difference between these timers. One timer is .T timer, one timer is .U timer. So if you are programming your sequence, if you need to use the timer to control this step, then you can use this compare T or compare U. So people will confuse what the difference between the T and the U. In the previous video, I showed the difference, but in this TI portal, I like to demonstrate again. So the .U, this timer will be interrupted if there's any cases, if this step is experiencing the interlock or the supervision, right? So if I put a timer here, let's see this different. Let's do this step 5. This step has this supervision. Let's do this demonstration first. Go online. Okay. Now I will trigger the fault. Let's go in. And here, let's watch this timer. Okay. So we experience a fault. Boom, the step is experiencing a fault. Meantime, we can see this timer now is stopped. But this timer is still working. Okay. See the difference? And now we clear this fault. Then we acknowledge that. And once I click this acknowledge, we can see this timer will recount again. So acknowledge, we will see this timer recount again. Meantime, we will see the difference between here. So the U means an interrupted step. That means anytime this step got interrupted, then this timer will recount again. But this .T, that doesn't care this. Once you jump to this step, it will start counting the time. Okay, we will see. This is like a normal time. It keep counting this time. This is the difference between .t and .u. Okay, again, let's show this fault again. Fault, timer stop. Reset and acknowledge. And let's watch here. Acknowledge. So we can see this timer will recount again. This is the different purpose of using these two timers. It's up to your process requirements. Okay, this is at the supervision. Now let's go back to this step. Okay, I will use here to initialize my sequence. Initialize. Wait for 5 seconds. But jump to the next step. Okay, now I got an interlock. Okay, as we can see here, because this step is got an interlocked, that's why this timer is now running. We can see. So this is another way to use .t timer. If you do like to use the interlock to temporarily hold your step, you can use this timer to hold your step. Okay, we can see if we jump into this step, as we can see, this interlock here is off. Okay, this interlock is off. So this action is off. And because we are using .u here as the transition condition, so this u is now running because this interlock is being held. Once this interlock on, then we can see this timer will start run. Okay, now I will turn on this interlock, turn on. It will start run. 5 seconds after, it will jump to the next step. Okay, so this is the .t and the .u. What's the difference between them? And in some cases, if you do like to use the interlock to temporarily hold your sequence, but you do not like any acknowledge to invoke any other person to come here to acknowledge your sequence, then you could use the interlock to temporarily hold your sequence and use .u timer to temporarily hold your transition. Okay, once this interlock on, then your sequence can keep running. Okay, it doesn't need any acknowledge. Okay, this is the difference between the interlock and the supervision and .t and .u here. Okay, now we can keep running this sequence. Number 6. Now we are at step 6. And once I turn on the condition 7 here, it will jump to the final step. But the final step is just one shot, so very quick. But we can see once it's finished this step 999, then it will reach to the end. So I will turn on this condition. Boom, run to here. So now there's no any place to show the active anymore. We can see the left side. It doesn't have any place to show the green. And if we go back and we can see the active number from here is showing 0. Okay, and how we know this sequence is complete? Okay, let's recall. So that's why I was using this status, this set S1 income event to set this bool. Once this bool on, that means this sequence was correct. That means this sequence has been done and a experience is execute this action. That's why this step is showing on, this complete is on. That's why I recommend we can use this set command to run it like a flag. Means, okay, this step was running, everything good, it complete this sequence. Okay, then next topic, how can we restart this sequence, right? Then we will use the command from outside. Okay, then we can do the reinitialize this sequence. Once it reinitialize trigger, then we can see the step 1 is active. Now this sequence is running, it's waiting for the condition to start. So that's why usually I will use one sequence condition just below this step 1. Basically, it's playing the role as a switch, right? So once it's on, it enables this sequence to keep going. So this is the transition condition. Once this condition on, if this condition is off, even the condition on, it won't run, right? This is running as a role like a car engine, that ignition, that key. right? Or some people will prefer using this way, using the off this way. So for example, if I turn this on, now I like to off this sequence. So I can off this sequence. Turn on, that means turn off. This sequence is being killed. Let's try it again. So reinitialize, firstly I turn off my condition. I will turn off my condition and let's reinitialize my sequence. Reinitialized, okay, reinitialized, okay, and then turn on. Once I turn on the condition, the sequence will start run. Okay. Okay. Then, if the first glance we jump into this sequence, and we do like to know, so which step is running there, right? So we can go online. The first glance we can see the left side. The left side can give us an old picture to show where we are now. Another way, if you do have like 100 steps in your sequence, so sometimes maybe you have multiple segments here, the sequences here, it's still a little bit hard for you to find the right spot. Then similar like the step 7 I showed before, we can use the track function. Go online and click this track active step. Then it will jump to here. More importantly, if we turn on, if this sequence is still running, so your monitor will keep focusing the current running the sequence. Okay, once we active this, my window, my monitor will keep tracking. If I lose this cursor here, so we can reactive this, turn off and toggle it. So once I toggle it, my screen will automatically jump to the active spot. Okay, this is the auto track. Then the next topic will be the sequence control here. So again, actually this area is one beautiful tool and leverage the graph, this structure to commissioning your system. So it has automatic mode, manual mode, and a semi-automatic mode. The semi-automatic mode, this is the one new feature compared with the step 7. Step 7 doesn't have this feature before. So I will show how that works. Default is running automatic. So automatic means anytime when the condition are on, then it will jump to the next step. It's running like a pretty normal. Okay, and the manual mode is very, very useful. So manual mode allows you to jump to any spot if you like to jump. Okay, and one beauty things compared with the step 7 and the TI portal, to jump to one step, for example, I like to jump to the step 3. Okay, I will write 3 here. If you recall, in step 7, to jump to from one active step to another step, you have to disable your current step first. I have to write 5 first here, disable it, and then rewrite 3 here and click the enable. But in TI portal, you do not need to do this. You directly write 3 and click this enable. Boom, we will jump to the step 7 here. And we can see, because we are at manual mode, even this condition on, your sequence will not keep running because we are holding this by this manual mode. If we switch to the automatic mode, then your sequence will start from here and keep running. Okay? If you try to temporarily hold your sequence, you can click the menu. Then your sequence, this engine, is temporarily being held. Okay, this is the manual mode. It's very helpful. Another feature I do like to specially introduce is a semi-automatic mode. Okay, so try to imagine early beginning of your commissioning test. If this condition, you are waiting for some sensors or some server drives in position, but in the real case, your sensor may be temporarily damaged, or sensor haven't been tuned, or your server drive, that condition, haven't got it ready yet. So now your sequence is being held here, right? So typically you can use the manual way to jump to the next step. Or if you are happy for your sequence, you are just waiting for a known feedback, but temporarily it is not on. So you do like to just keep running your sequence as designed before. How we can do this? We can use this semi-auto mode. Okay, the semi-automatic mode, as shown here, is named ignore transition. That means it will still do the action, but it will ignore the condition on or off here. Once you click this ignore transition, it will jump to the next step. Click, boom. Even this 6 was not on, the sequence still can run. Okay? Again, the 7 it is not on. If I click, it can still run. Jump to the next step and finally turn this on. That sequence complete. So this ignore transition will be very helpful if some of condition temporarily they are not on. But however, you need to be very carefully because some transition is waiting for the tool in position. Some cylinders need to be open, then allows you to do some other work. So if you directly click this, continuous click this, then some tools may be crashed because some actions wasn't fully complete, right? So again, this is logically allows you to jump to the next sequence and do the actions. It's providing you a very convenient way to do the commissioning. However, it will potentially also cause the tool crash. So you need to be very carefully. But again, this auto, manual, and the semi-auto mode are very useful during the commissioning. To be honest, this is one of the very key reasons I prefer using the graph to do the sequence control compared with the ladder logic. Okay, this panel is very useful. And finally, topic, as I introduced when we are talking the step 7. So the step 7, the right side is pretty rigid, the width, right? But the TI portal is very flexible. So you can drag this area very flexible. Okay, and then any branches, they can do the parallel branches here. The step 7 was not doing a very great job because if you have a multiple parallel sequences, they will do like a ladder style. So it's really hard to organize, figure out the relationship between these branches. But in TI portal, all the parallel branches, they are the same level. This is the wheel and the commissioning friendly and very easy for you to figure out the relationship between those branches. Okay, this is the brief topic showing my personal experience, some key point, tip and tricks by using the TI portal graph programming. Okay, hope you like it. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.